In many facilities, blockage in tanks and hoppers is a cause for concern and trouble. There are various reasons for clogging, which are related to the configuration of the tank. What type of tank are you using in your facilities?
In the tank on the left, the cone is set at a sharp angle. On the right, greater storage is enabled, but the cone's angle is less sharp. To see how these differences affect the flows inside the tanks, we did an experiment with an hourglass. As you can see, the flow is smooth on the left. This is called mass flow. However, on the right, you can see funnel flow.
It would be ideal if we could have mass flow in all equipment, but due to limitations on storage volume and other reasons, many facilities are still using funnel flow tanks.
Funnel flow generally occurs when flow is fast in the center and slow along the side walls. Only objects directly above the hole are released first, and the area around it crumbles and flows out little by little. Older materials are left to build up in the middle, creating safety and health problems.
In other words, with funnel flow, to prevent blockage, some sort of supplemental step is required to aid in the flow of materials. EXEN has a variety of devices that can do this. One of them is the ball vibrator.
It is useful in tight spaces or places where you need just a little vibration. The ball vibrator uses compressed air to increase rotation speed of steel balls and create vibration through strong centrifugal force. Take a look at the inside of this miniature tank with a ball vibrator attached to the pipe on the experimental device. Simply by adjusting the air pressure, you can choose the optimum vibration rate and centrifugal force. And thanks to its compact size and simple construction, it's easy to maintain.
Here we will describe one more cause of blockage. Are you familiar with the angle of repose?
The angle of repose is the angle of incline that ensures stability and prevents unintended collapse during the piling of sand, rocks, or other materials. This varies according to the size of the particles and the roundness. If the angle is not greater than the angle of repose, the powder and particles do not flow. In such cases, it is necessary to apply vibration or other means to promote the flow. In other words, if the angle of the cone portion of the tank is larger than the angle of repose, blockage occurs. Materials that tend to form the blockage, known as rat-holing, as you can see here, also include carbon black, PVC, and other materials without strong viscosity. As in the corrugated silo, when the dust included in lime is collected on a flat floor, rat-holing develops.
One effective way to prevent this is by using this blaster. Take a look at its power.
In the experimental device, a small blaster is installed. This explosive air power is expelled instantaneously. Because it uses compressed air, it is safe and its operating costs are minimal. Causes of blockage, in addition to rat holes, vary according to the shape of the tank and materials being handled. A phenomenon called bridge is common when the exhaust port in a tank is small. One must be especially careful with sand that has high moisture or materials that easily become damp. Salt and urea can also cause this problem. Because these materials tend to harden during periods of high humidity, special caution is required. In addition, arching and attachment to walls tend to occur with the materials you see here.
It's almost impossible to make equipment that causes no clogging for any type of material. Before blockage occurs, please work to prevent it.
With relay knockers and piston vibrators, through the force of compressed air, the pistons exert force on the walls of the tank, removing blockage and adhesions. These and other useful devices are available from EXEN.